So let's do another example using the BiotSavart law, but this one's a lot easier. Suppose I have this weird looking wire. Here's a central point, and I've got a circle around like this, and then I've got a wire that comes like this. Whoops, I didn't draw that very well. Sorry. So here's what's given. I've got a wire that approaches this and then moves in a circle around like this and then goes away. Okay, and so, well, let's have the current. I will stick with it. Here's the current coming out. So it comes in like this, goes around in a circle, and goes out like that. What's the magnetic field right here? And we'll give this distance r, and this has a current of I, and I want to know what's the magnetic field right there. Well, we got three pieces to look at using the BiotSavart law. If I come in like this, let's go dB equals mu naught over 4 pi times I times the integral of ds cross r hat over r squared. The key thing, though, is to look at ds cross r hat. Pay attention over here, please. Here's my ds. You have to learn to think with calculus here. ds, here's my little ds, but what is my r hat? My r hat is in this direction. What's true about ds and r hat? They're parallel. What happens to a cross product when the vectors are parallel? It's 0. So this and this, when ds is going away like this, here's ds over here, you get nothing. There is no magnetic field contributed to this point in space due to the current here or the current here. But the current over here, it is. Okay? So that's all we need. And we need this angle. We'll call this angle theta from here over to here. So dB is going to be, or actually, let's just integrate now. Mu naught I over 4 pi. Now, what's a constant here? R is a constant. And so it's r squared, so it just comes out as r squared. And so now all I've got to do is integrate ds. Okay, oh, and then we have this cross r hat. Let's get rid of that. If the current is going like this, and my r hat is like this, r hat crossed into there, it's going to be into the board. The magnetic field is going to be into the board here. Well, what's the length of this? What is the length of this if I'm given theta? So the integral of ds is just s. That is the arc length here. But s is equal to, well, think about what theta is. And theta in radians, and I'm trying to hurry here. Theta in radians is equal to s over r. So s equals r theta. So I plug that in here. And so I get b is equal to mu naught I over 4 pi r squared times s, but s is equal to r theta. R goes away. This is mu naught I theta in radians over 4 pi r. And that's the magnitude of the magnetic field. The direction is into the board at that point. Okay, so this is the kind of thing that you're going to, on the AP test, I saw the BiotSavart law a couple times on the AP test, but usually it's something like this, where you really don't have to integrate. You just have to put all the pieces together. Okay, if R is a constant, you've got it made. All right, that's it for today.